So in example 4, again, it's going to ask us where it's defined. Where is it defined? And then it's asking us to simplify. And here it says the word simplify, and you have to know that simplify means write it as a mixed radical. So first of all, we have the square root of 45a squared. Can you see that it's a square root? We have an even index. So we have to check positive numbers and negative numbers because we know we can't take the square root of a negative. Now, I'll write it out for now, but what happens if you put a positive number in for a? It's good, right? Green light. Yes. What happens if you put a negative number in for a? It's going to be fine as well, right? Because that negative number is going to get squared. Because when I put in -3 times -3 will be positive 9. I'll get a positive number inside. That's okay. It's good. So as far as where is it defined, a can be any number. It is always defined. Now, when we go to simplify this, we'll simplify the number, and then we'll simplify the variables. Okay? We're looking at square roots. So with the number, we look at our powers chart and powers of 2. Is there a power of 2 that divides 45? 4, 9, 16. Do any of those divide 45? Yes. 45 is 9 times 5. So basically what I have is I have the square root of 9 times the square root of 5 times the square root of a squared. Square root of 9 is 3. Can I do the square root of a squared? It'll just be a. Now, that is simplified. Technically, we just said a could be a negative number, right? And we learned about the principal square root. Say, whenever you take the square root, it always pulls out a positive number. So in order to make sure that this a is positive, we add absolute value bars around it. So our final answer, when writing it, and for most things mathematically, people end up forgetting those absolute value bars. But that is correct, the correct way to write it, because a could be a negative number, but when it gets pulled out in front, it's a positive number. Let's go to B. Again, we have a square root, and so we're going to have to check positive numbers and negative numbers. If you throw a positive number in there, is it going to be good or is it going to be bad inside the square root? Bad. Because if I make b a positive 1, 1 to the 9 is going to be 1 times a negative 27 will be a negative number, and positive numbers will cause there to be a negative number inside, which is bad.
Can't do that.
And then negative numbers. If I plug in a negative 1 to the power of 9 will still be negative, times by a negative 27 will be positive. This is good. So for where it's defined, we would say that b has to be less than or equal to 0. Now to simplify it, it's a square root. Does 27 divide nicely? Yes. 9 and negative 3. b to the 9. There's two ways you can look at this. Probably the easiest way to see it is if we write out, my goodness, 9 b's. 7, 8, 9. If you write out 9 b's, what a square root does is every time you have two of them, one could come out. Does that make sense? Every time we have a b squared, we could pull a b out in front. So how many pairs do I have? 4 of them. So now when I'm pulling things out, the square root of 9 is 3. I have 4 pairs of b's. So 4 b's would be pulled out, and b times b times b times b would be b to the power 4. And inside, I would have still a negative 3 and still 1b. The question you ask yourself is, do I need absolute value bars around my b to the 4 this time, or is it okay? It's going to be okay this time because anytime you do something to the power 4, it's going to be positive. Even if it's a negative number, negative times negative times negative times negative will be positive. So I don't need to add the extra absolute value bars on this one. And this one is simplified where b is less than or equal to 0. Here's c and d. Again, we have a fourth root, so we're going to have to check it. We're going to check our positive numbers. We're going to check our negative numbers. If you throw a positive number inside here, you multiply it by 7, that's going to be good. Positive numbers work. If you plug in a negative number times 7 will be negative. That will not work. So when we try to decide where this is defined, it's only working for positive numbers, so z has to be bigger than or equal to 0. Can we simplify this one? Is there a power of 4 that divides 7? No. In order to pull out a variable, you would need to have 4 of them multiplied by itself. Z times z times z times z in order to pull out 1. But we only have one z, so this question is done. It's already simplified. Finally, we get an odd number. Finally.
Yes.
Because the odd numbers you don't have to check, positive and negative. The odd numbers are always defined, so we can write this right away. Then when you go to simplify it, you have to ask yourself, is there a power of 3 that divides 24? 24 is 8 times 3. And if I have y to the power of 5, that's like having y times y times y times y times y. And now, since it's a cube root, I need to have a group of 3 in order to bring 1 out. Cube root of 8 is 2. Cube root of y is y. And you don't need absolute value bars because if it's a negative, you could pull out a negative. If it's positive, you'd pull out a positive number. And what are we left with inside? We're still left with a 3 inside and a y squared. Just going to add one here just to look at what would happen if you had the 6th root of negative 3y squared.
That would be bad.
That would be bad. First of all, you do have to check positive and negative. So in this one, if you were doing this one and you check positive and negative, can you see that when you plug in a positive number, you'd get a negative inside? That would be bad. Can you see that when you plug in a negative number, it would still be negative? So that would be bad. And so this one we would say is undefined. Can't do that. For question number 4, 10, 11, and 14, did I give you a question for question number 3? For question number 3, it's 6. For question number 4, 10, 11, and 14. For question 3 is 6. And we have 5 minutes, so you can get started on that.